Suppose that we have given a function f of x equal to square root of 5 minus x, and g of x is equal to square root of x square minus 4. So let's assume we have given these two functions. Our goal in this example is to find by using these two functions f and g, our goal is to find the new functions. That means we need to find what is f plus g, we need to find what is f minus g, we need to find f times of g, we need to find what is f divided by g. So we need to find these four functions and then also their domain. So this is the question. So how do we work on this problem? Okay, so let's try to see if we can find the function f plus g here. Okay, so how can we find f plus g of x? So the f plus g of x is actually the sum of the function f and g, right? So which by the definition is actually just f of x plus g of x, right? So we just need to add these two functions. So what is the rule that we have corresponding to f of x? Is given as square root of 5 minus x, right? So let's copy that then. So f of x is square root of 5 minus x. Okay, and then what is the rule corresponding to g of x? It's actually square root of x square minus 4, right? So let's also have that. So square root of x square minus 4, and since we need to add these two functions, so let's just add them together. And that's it. On this particular case, we cannot combine further, right? It's difficult. I mean, it's not possible to combine those two radicals, so we can just leave it like that. And then this together, square root of square root of 5 minus x plus square root of x square minus 4 is this sum of these two functions f and g. So f plus g is the this function over here. Very easy to find the new function, right? So let's try to do the same thing to find the f minus g of x by using the same idea. Let's use the definition of the difference of two functions, which is f of x, right, minus g of x. So that's what we need to do. But we already know what is f of x, which is given as square root of 5 minus x. So we copy that, minus square root of x square minus 4, and then this is the difference between two function f and g. So we find that out. Let's find f times g. So f times g means the product of these two functions f and g. Do the same thing. So whatever is the function f of x, multiply that with function g of x. That's it. So we know that function f of x is given on this problem as square root of 5 minus x, right? We just need to multiply that with square root of x square minus 4. On this particular one, either you can leave it like that, or if you want to actually multiply these two radicand, we can actually combine the radicals and then write down also in this way, and then you can still multiply these two expression over here and then expand and then see if we can combine, or just leave it like that. But this is already a good product function. Okay, now similarly, to find the cosine function, what we can just do is we need to divide the function f, right? So function f, whatever is given, divide that by g of x, and we know that the function f of x in this problem is given as square root of 5 minus x divided by square root of x square minus 4 is the function g, right? So that's what we have. We can just plug that in. Done. So this is our cosine function. Okay, so we have already figured out these new functions from this given old function f and g, right? So just we need to add, subtract, multiply, or divide together, and then we get those. Now the next thing we need to figure here is how to find the domain of these function. So we have not done that yet. Now to find the domain of these new function f plus g, f minus g, f times g, and f divided by g, we need to first find what is the domain of function f and what is the domain of function g, and then only we'll be able to find the domain of these new function. So let's try to find the domain of these given function f and g first. Okay, so let me work over here. Okay, first of all, I want to find the domain of the function f. Okay, so how do I find the domain of f? So what is the function f given over here? We have given square root of 5 minus x, right? And we know that if we have the square root function, which is over here, right? If we have the square root function, then under that radical sign, under this square root, right, whatever expression we have, which is 5 minus x, that has to be non-negative, right? So then only the function is defined. So if that is the case, 5 minus x has to be positive, sorry, or non-negative for that under root of that square, this rule to be defined. And then that whatever solution of this inequality over here, that will give you the domain of this function. But how do you solve this one? We can add x on the both sides, so we'll get 5 is greater than or equal to x, right? So wow, we already get the solution set. Do you know what is this one over here? What we can do here is probably you can look into the real line here. If you have the real line from negative infinity to positive infinity, what does this solution set mean? Set of all real number which is less than or equal to 5. So if 5 is somewhere around here, then all the real number which are less than or equal to that, right, less than or equal to 5, less than or equal to 5 is the domain of this function f. So if you want to write down that on the interval notation, the domain of f will be negative infinity to 5 and including 5, right? So we want to write down the bracket there. Okay, so let's try to find in a similar way the domain of g. Domain of the function g. Okay, so again the function g is given here as square root of x square minus 4. By using this similar idea that we have used over here to find the domain of f, you know that we have the square root function here, and that is defined only if this expression under that square root is actually non-negative. So in that case, x square minus 4 has to be non-negative. So now just solve this inequality. We can add 4 on the both sides, so we get x square is greater than or equal to 4. Okay, what does that mean? For what real numbers this inequality is satisfied? We need to look into that. So let's try to see here on the real line. Let's say if we have negative infinity to positive infinity, then oh, by the way, why don't we just check where x square is equal to 4? We know this is very easy to solve this equation. We can use the principle of square root, right? So and then we can get x equal to plus or minus 2 as a solution. So exactly at x equal to minus 2 and exactly at 2, right, x square will be equal to 4, and then at that location this is actually 0, right? So yeah, I mean 0 is fine, square root of 0 is 0, so that is in the domain of the function. But not only that, if you choose any real number which is greater than or equal to 2 and square that, you'll always get the x that quantity will be greater than 4, right, greater than or equal to 4. So if that is the case, these numbers are on the domain of the function. At the same time, in the similar way, you can clearly see here, if you choose any real number which is less than negative 2 or equal to negative 2, whatever number real number you choose, square that number will be also actually greater than 4, right? For example, negative 3, square of that will be positive 9. And that's clearly greater than or equal to strictly actually greater than 4, right? So I mean, if that is the case, then negative 3 is in the domain of the function. But not only that, all the real numbers over here will be in the domain of this function g. So if that is the case, the domain of g will be all the real number from negative infinity to negative 2 including negative 2, right, and all the real number from 2 to infinity, and we can combine these two by the union sign, and this is the domain of g. What we have so far figured out is what is the domain of f and what is the domain of g. But our goal here, remember, on this problem is to find the domain of this new function. Okay, so let's try to find that. So how do you find the domain of f plus g? So how do you find the domain of that? The domain of the sum of the two functions is actually the common domain between the domain of f and domain of g. That means whatever real numbers you have that is in the domain of f, and whatever real number you have that are in the domain of g, we just need to find the common domain between those, just to find the common real numbers between both domain. That's it. That will be the domain of f plus g. So if you look into these two picture over here, and if you are interested in finding the domain of, let's say if your goal is to find the domain of f plus g, then you just need to see the common domain here between, just need to look into what is the common real numbers, right, that are over here and then on these intervals. So how can you find that? Okay, let's try to draw a real line over here from negative infinity to positive infinity, right? If you look into here, the domain of g, you can clearly see that the domain of g is set of all real number which is less than or equal to negative 2. So if negative 2 is over here, this is the domain of g, right? And then from 2 to infinity, this is the domain of g, right? So that's what we have. But you can look into the f. The domain of f is actually set of all real number which is less than 5 or equal to 5. So if 5 is somewhere around here, the domain of f is actually including all of these real number over here. So I have these two different color. Domain of f is in blue, and then domain of g is in the let's say what, yellow color. Okay, so if you look into that, what is the common domain between these? So where are the two colors, like it's kind of overlap? You can clearly see it's overlap somewhere over here, right, up to negative 2, and then between 2 to 5, and that is the common real number which are on the both domain of f and domain of g. So if that is the case, those real number has to be in the domain of f plus g. So if that is the case, domain of f plus g will be all the real number from negative infinity to negative 2, that's for sure, right? But also from 2 to 5, and that's the domain of f plus g. So all the real numbers over here all the way up to that location, and then from 2 to 5. That is the domain of f plus g. The idea is same for the domain of f minus g. It's also the domain of f minus g is also set of all real numbers which are in the domain of f and then domain of g. So if that is the case, it will be the same answer, right? So because we have already seen that for the sum of the two function, so that these are the real numbers, whatever real number we have on these intervals, those are on the domain of f and g. So that will be on the domain of f minus g. In a similar way, we can say that the domain of f times g is also the same thing, the domain between the real numbers which are on the domain of f and then domain of g. So in that case, we can write down the same thing here. The only thing we need to be a little careful is to look into the domain of this cosine function f over g. You can see here the cosine function that we have obtained earlier. We have something is on the denominator, which is square root of x square minus 4. And you know that if we have 0 on the denominator, the function is not defined. So if that is the case, the domain of f over g will be set of all real numbers which are in the domain of n g. Okay, that's fine, like what we have found on f plus g, f minus g, and f times of g. But we need to exclude the real number where the denominator is 0. So if that is the case, you know that the domain of the possible domain of f times f divided by g is definitely from negative infinity to negative 2, from 2 to 5, but exactly at negative 2 and then 2. You can see here when we plug back in on the denominator, or you can just check x square minus 4, set that equal to 0, and if you solve this for x, we get x equal to plus or minus 2. So if that is the case, at x equal to plus or minus 2, the denominator is 0. So we need to exclude these two numbers from the domain of from the possible domain of f over g. So how can we do that? Well, we just need to remove this bracket sign over here at negative 2 and positive 2 by the parenthesis. So if we write down the parenthesis, that means we are excluding the the in point. So on that case, in this case, -2 and 2 are on the in point, right? So I just need to remove that. All right, so this is the domain of this new function that we have given, and then we have already discussed how to find these new functions.